All right, let's talk about something that is absolutely critical when you're building secure AI systems. We're going to dive into handling authentication and secrets within MCP, which, as you know, is all about safely connecting your AI models to external tools. The core idea is actually pretty simple, but getting the details right, well, that's everything. So let's get into it. So, what's the big deal here? Why does this matter so much? Well, this slide lays it out perfectly. On the left, you see the danger zone. This is the common, easy way to do things, where the model itself gets its hands on the API key. And that key can so easily end up in your logs, your prompt history, anywhere. But now look at the right. That's the MCP way. The model just makes an abstract request, a tool call, and the MCP server is the one that actually handles the secret. The model, it never even sees it. And that brings us to the golden rule, the absolute #1 non-negotiable foundation of MCP security. I'm going to say it again because it's just that important. Models never see credentials. Ever. Think of it like this. The model's job is to figure out what needs to be done. It's the MCP server's job to figure out how to do it securely. That separation is the whole game. Okay, so we get why this is so critical. Now let's dig into the how. You know, it's not a one-size-fits-all situation. There are really 4 main patterns for handling credentials, and each one is basically a different tool for a different job. Picking the right one is going to be key to building a system that's not just secure, but also makes sense for your needs. First up, we've got the simplest one, the one you've probably all used before, environment variables. It's exactly what it sounds like. Your server code just grabs a secret, like an API key, straight from the environment it's running in. Simple as that. But, of course, there's a trade-off. On the one hand, yeah, it's super simple, it's a standard practice, and swapping out keys is pretty easy. But the downsides can be a real problem for a real application. You might have all your tools sharing the exact same credentials, there's no way to do per-user authentication, and you still have to figure out how to securely manage those variables in production. So it's great for getting your feet wet, but you're going to outgrow it fast. Okay, our next pattern kind of builds on that last idea. Let's talk about configuration files. This approach gives you a bit more structure by letting you put all your credentials in one central place, like a single JSON or YAML file. So this is definitely a step up in terms of control. You can start assigning different credentials for different servers, which is a huge improvement. You can even still pull in environment variables from your config file, which is handy. The catch? Well, that config file is now basically a treasure chest of secrets. You have to store it super securely, and anytime you need to rotate a key, you've got to update and redeploy that file. All right, now we're getting into the big leagues, patterns for when you have multiple users. OAuth is the gold standard here. It's how you let your application do things on behalf of a user with their specific permissions, but, and this is key, without ever touching their password. The power here is just incredible. You get user-specific permissions, you can define really granular scopes of what's allowed, and users can yank that access at any time. It's awesome. But that power comes at a price. OAuth is notoriously complex to get right. You've got to build logic to handle refreshing tokens when they expire, and, there's a little bit of friction for the user who has to click through that allow screen. And finally, we have the enterprise-grade, top-tier solution, Secret Vaults. We're talking about services like HashiCorp Vault or AWS Secrets Manager. Instead of having secrets live on the server at all, your server asks a secure central vault for the secret it needs, right when it needs it. For production environments, this is really the gold standard. You get one place to manage everything. You get audit trails to see who accessed what and when, and rotating keys is a breeze. It's a compliance officer's dream. Of course, it's not a free lunch. You're adding a new piece of infrastructure you depend on. There's a tiny bit of network latency, and yeah, it'll add a line item to your cloud bill. Okay, so we've covered the how of authentication, but that's only half the battle. Now we need to talk about the what. See, it's not enough to just use a secret. You have to make sure that secret has the absolute minimum level of access it needs to do its job, and nothing more. This is the classic principle of least privilege. You can think about this in 3 layers, each getting more and more specific. At the top level, you have per server scoping. It's simple. Your GitHub server gets GitHub credentials, your Slack server gets Slack credentials. They don't cross the streams. Then you can drill down to per tool scoping. A tool that just reads a repo should only have read-only permissions, right? While a tool that deletes a repo needs something more powerful. And finally, the most granular level is per user scoping, where every single action is performed using the permissions of that specific logged-in user. Phew, we have covered a ton of ground. So let's try to boil all of this down into a really practical guide of what you should be doing, and just as important, the common traps you absolutely have to avoid. Think of this as your security cheat sheet. Just look at the don'ts column. Never, ever log credentials. Never store them in your code. Never, ever check them into Git. I know these seem obvious, but you'd be shocked how often this is how secrets get leaked. Now look at the do column. Use vaults in production. Scope your permissions as tightly as possible. Rotate your keys on a regular schedule. If you just follow these rules, you are way ahead of the game. Now, here's a pitfall that's really sneaky and so easy to overlook. Your app is going to fail sometimes. It's going to throw errors. But the way you handle and report on those errors can itself be a massive security hole if you're not paying attention. Let me show you what I mean. On the left, you've got a bad error. The message says authentication failed with token SKABC, and whoops, you've just blasted your secret API key into your logs for everyone to see. Now on the right, we have a good error. It uses a safe error code, a generic message, and then a helpful hint that gives you a clue without exposing a single sensitive character. This is how you give good feedback without giving away the keys to the kingdom. So, we've seen why keeping secrets away from models is totally non-negotiable. We've walked through 4 different patterns for doing it, and we've covered the crucial ideas of scoping and safe error handling. All of this really leads us to one final, really important question that I want you to ask yourself right now. When you think about your own projects, which of your tools needs a security review? Taking what we've talked about here and actually applying it, that's the first real step to building AI systems you can truly trust.